All right, the next question, we're going to look at question 18 from chapter 13 again. And this is, again, a very typical essay question. If you memorize it or if you understand it properly, it should be really simple for you to do. Right, so remember when you talk about carbon dioxide, what actually happened is that we can't detect carbon dioxide. What do we detect? We detect blood pH. So you have to first explain to me how is carbon dioxide detected. Then when it's detected, you can then do all your things through your heart, through your lungs, and you can fix it. In this question, I think it's quite clear. They give you the medulla oblongata and it controls two parts, which then is the two parts that you use to regulate your carbon dioxide. And note that over here, they also give you a pathway to come back. Why? Because remember, carotid body and aortic body is where you actually bring the information, the receptor, the sensory information actually comes from here, your chemoreceptor. So let's start from the very simple one. How can carbon dioxide be detected as a pH? How? Because carbon dioxide reacts with water, that becomes carbonic acid. That becomes carbonic acid. And so, of course, when you have acid, what do happen? Blood pH decreases. And remember, whatever the question is, oxygen 也好, carbon dioxide 也好啦, whatever they give you, you should always link it back to blood pH because that is a thing you are detecting, okay? That is a thing that you're actually looking after. So, blood pH. Then, from here, you get to the nervous system part. It is detected. This is detected by peripheral chemoreceptor. Again, because I think this question, it purposely tell you that there is carotid body and aortic body. You should definitely give a bit of focus to these two bodies, right? There are the peripheral chemoreceptors in aortic and carotid body. So we have the chemoreceptor from these two bodies. Of course, we also have central chemoreceptor. We have the medulla oblongata themselves, but you can choose not include it because this is like maybe a 6-mark question. It's not like everything must be included lah. But of course, if you have the chance, this is not just 2 mark, but two sentences, by the way. It can be much longer if you want to. So up to you. You can definitely make it longer. This is just one of the sample scheme. Okay, one of the sample scheme. Now, when you detect it, we have to transmit lah. So nerve impulse is then transmitted to your medulla oblongata. And what do? As a brain, you are supposed to control what happened next. So what happened next? You should then know, you need to send it to your actual effector. Who's the effector here? You have the control center. And I think over here, they give you specifically for respiratory. In fact, it's not just respiratory, it's also, because respiratory control respiration, fair. But we also have our heart. Heart should be controlled by cardiovascular, right? So anyway, the question focused on respiratory lah. So I think, actually that's true. Maybe you can just ignore this arrow here. They don't really care about heart for this schema. Again, for this schema. You yourself, when you write any essay in exam, of course you write the fullest possible because you want to get the maximum mark. But just for here, because it's done, this is not really given, so it's fine. So yeah, let's just focus on your respiratory. Okay, your respiratory. So your respiratory control center is the one that need to transmit nerve impulse out because medulla oblongata is a huge space. It's a huge place. Who control respiration? Respiratory control center. So this guy is going to send nerve impulse to different places. And you can see here, specifically, the respiratory control center should send to, sorry, not send, transmit. Should transmit to, already written for you, already written so clear out for you, intercostal muscle and diaphragm. So put it down. Transmit nerve impulse to these two guys, intercostal muscle and diaphragm. Remember, if you want to affect your breathing rate, this is a two guy you look after, you look for. Again, even back in your chapter 8, you also learned that the two things that changes your volume, pressure, and everything. What is the thing that changed? Your rate intercostal muscle and also your diaphragm. That is the two things that you can control as a muscle. You can control the breathing rate. So yeah, you have to send to these two guys as the diagram suggested. Then you do the rest. What do you do? What do? They should contract faster lah, right? Because they want to breathe. So yeah, very simple. Intercostal muscle and diaphragm, they are gonna contract faster. They're gonna contract faster. And that to say, a simple summary is that breathing rate increase because you are doing it faster, you breathe in, breathe out faster, breathing rate increase. You can also put ventilation, right? In fact, if you remember, there's like a combo, right? I think I mentioned a combo before. Breathing, ventilation, respiration, and gaseous exchange. These all sort of refer to the same thing, but they just sometimes are marked differently. So try to put all of them down if you're possible. Breathing, ventilation, gaseous exchange, and respiration increases. Yep, and next one, let's go back to the question. The question asks for carbon dioxide. So how can this action affect carbon dioxide? By the way, if I'm going too fast, of course I am, because I don't need to wait for you to copy. This is a video, you can pause it. Yeah, if you are in need of more time, just pause the video. Thank you. So yeah, moving on, we are gonna have our, going back to the question, we are gonna conclude it by basically saying, oh, now you're done with your breathing rate. How does it help? It helps you by removing the carbon dioxide. Excess carbon dioxide is removed. And when they are removed, you can then make it, you can then basically conclude the ending. The ending is everything go back to normal. So ending, carbon dioxide, again, I think the question says concentration. So let's just use the word concentration. I will prefer the word partial pressure. If you remember, the word partial pressure is the same as concentration, but it is used for gases. If you have a gases, carbon dioxide, oxygen, yeah, you should be using the word partial pressure, but still it's okay. The question says concentration, so I'm gonna just use that concentration. Again, don't forget your ending must always be completed. How? Just now it was too high, increase. Now you should decrease it back. Decrease back to normal. You see, because the question was asking for carbon dioxide, your answer should then also refer and reference back to carbon dioxide. Don't give me another answer, say blood pH. You can. Oxygen can, but that's not the focus. You can give, but you should definitely not forget. You should remember to give carbon dioxide because that's the main thing you are discussing here. Okay? Yes, that's it. Okay. Right, thank you so much. Oops.